So welcome to the Vermont.net user group. Tonight's presentation is going to be using the Decorator pattern to address cross-cutting concerns. I usually avoid the whole "who is this guy" because I said usually. Yeah, who is this guy? Why is he talking? So my name's Rob Hale. I'm a senior engineer here at My Web Grocer, and I'm only saying this really for two reasons. One is I know we have a number of new people that don't actually know me. So after the session and whatnot, please make sure you swing up and introduce yourself. And the other reason was because I had to share this. So My Web Grocer does the Dragon Boat Festival the last few years as a fundraiser out on Lake Champlain. I think it's for breast cancer. And I paddled the last 2 years. Well, I paddled the first year 2 years ago. Last year I was an alternate. This year they sent out their promotional materials, and it was a gas to find on the link my photo dressed up as the Vikings. You might be able to see it on the back there, but that was kind of funny.
That's so you.
Yeah. So our team dresses up as Vikings. We're the MWG Marauders. So if you're inclined to support us, then awesome. It is a fundraiser for a great cause. So yeah, my name's Rob Hale. I've been with My Web Grocer for 4.5 years. I've been developing in one form or another for nearly 20 years now. I started out doing kind of support and installations at IDX, moved into doing a systems and software analyst role for their internal IS shop, and pivoted to be a developer. So of the nearly 20 years, pretty much, I don't know, 16 of it has been actually hammering out code. A lot of that was Oracle and some VBA stuff, and for the past several years it's been C# and SQL Server. And since I came to My Web Grocer, because the application is all web-based, I've been doing a lot more HTML, CSS, JavaScript. But the nice thing is I've really kind of got bit by this book that I read. It's called Head First Design Patterns. It's put out by, the Head First series is an O'Reilly imprint, and it's one of the two most influential books that I've read as a developer. It just got me thinking about code in a very different way, so the design patterns. So if you look back at the presentations I've done over the past few years, they tend to center around this. So I thought this would be the next one to do now that I'm starting to do presentations again. So what is a cross-cutting concern? Let's start with that. So a cross-cutting concern is anything that's a common functionality that's going to affect any number of classes. It's not specific to the domain of that class. Examples would be things like authentication, right? Is the user who they say they are? Authorization. Can they do what they want to do? Now, if I'm calling a print function and for some reason we want to protect printing, I need to do both of these things, right? I need to authenticate that you are who you say you are. But data access is probably a better example of being able to pull up a particular record type. Is the user who they say they are, and can they access what they'd like to? Other things are like caching is a cross-cutting concern, as is communications to maybe a queuing system. Exception management can be treated as a cross-cutting concern, and validation as well. The one that I'm going to use for our demonstration tonight is one that hopefully we do a lot of, is logging. Logging for important activities that happen in the system that maybe we're going to look back to and aggregate to find out. Like at My Web Grocer, we do logging to find out shopping behavior so that we know are people adding to their cart primarily as a result of searching for a product, or are they navigating through the category structure, like going groceries and then dairy and then milk and then adding it to their cart. So we're interested in that kind of thing, in aggregate, finding out what's the best way we can improve the system. Other logging is for things like errors and warnings and conditions that we want to do. So it's something I've got a little experience doing, so it was an easy one for me to focus on as a cross-cutting concern for the presentation. How do we normally address introducing logging into our applications? I'm going to pull up just do I have it up? I've rebooted my machine. I don't. I have to pull it up. So this is a very simple, obviously, a simple example where we have just a console application called program, and it news up a processor. We execute the processor, and then we stop and I read the line. So what does execute do? This is it. We're going to call execute. We're going to say, hey, we're starting to execute. And we're going to write a line that says, we're doing our job. Notice that the right line, I'm using a logger, this is a log for net logger. Okay, so I've declared that as static to the class. When the class executes, we say, here's some information, we're starting to log, or we're starting our execution. And then rather than actually write a class that does anything, the easiest way for me to do the demo is to what? Console write line that the processor did something. And then we say, hey, we're done with our execution. And if anybody's surprised, so one of the things I did, before I get to that, is in the app config, I've defined two loggers to be active right now. One is the console appender, which means that this is going to show up side by side with everything that my program puts out to console.writeLine, and also the debug appender. So the logger will actually show up in the output as well. And we'll show that in a moment. So very simple program, but it demonstrates that I actually can write a program that executes. So there's our code. Starting execution, we're doing a job, and we're done with the execution. And just so you know, the Decorator presentation.processor, that's coming as a result of the logger.info. And if we look in the output, we can see that that logging is also happening, same actions, putting it out. That's one of the advantages to a logging framework like Log4Net, is you can have different appenders. Just by modifying the web config, I could have this output the same information to a file that we store off later. We could send it to a pipe and enter it in a database. I mean, we could do all kinds of crazy things. But for the purposes of the presentation, it's enough to know that we're just outputting stuff. Okay. Let's go back to the presentation. Now, the problem with what we were seeing was it violates this idea of a single responsibility. So one of the design principles that you want to try and get your head wrapped around if you're doing object-oriented coding is that every class should have a single responsibility. And that responsibility should be encapsulated by the class. And everything should be about that class should really have to do with that responsibility. Now, what do I mean when I say responsibility? Responsibility is if I have to change something in the class, if something about the program changes, I really want to have one reason to change a class. So if we look at our example, how would execute? If I wanted to change logging, I'd have to go into the execute method. If I wanted to change what execute was doing, I'd also have to go into the execute method. So we can see that we've got two responsibilities. We're violating that idea of a single responsibility within the class. Okay? So that's why this, and this is, you know, very, I know it's simplified, I've got 3 lines of code, but you can see what I'm saying in terms of it's a very common kind of scenario, very typical implementation. Now I know, geez, maybe 1.5 years or 2 years ago, Tom Cooley did a presentation where one of the ideas he touched on was dependency injection, also known as inversion of control. And so I want to just speak to dependency injection for a moment, and we'll refactor this code that we just had. So I'll cut back over here, and we'll create a new project. And we'll call it our dependency injection version, and I'll set that as my startup project, so I only have to hit F5 once. And because I need Log4Net to prove my points, I'm going to add that in using NuGet. Everybody that is using Visual Studio, I'm hoping, is at least comfortable in some level with NuGet. If you're not, there's a couple of good resources on the web for it. I like it in terms of for demos. It's very easy to pull stuff in. For when we're using it for our production systems here at My Web Grocer, I'm not super keen on it because I don't like the way tying it back into the into our source code repository and into our build automation server. We haven't come up with a good solution for that yet. So I now have to do one other thing, which is to tell my program to scan the web config or the app config file for our log4net config. And that's done. And I think what I'll do is just make my life easy and copy this guy to here. So that's my app config. So we're taking all the same settings that we had before and just dumping it into the dependency injection. So let's open up the program file. Okay. So what would be different in this situation? I need to close a little bit of files because my OCD will kick in. Well, we're still going to need a logger, and we still need if we look at the original program here, right, the processor. So we're going to need a logger and we're going to need a processor. Right now, in the typical example we had, they're both wrapped up in the processor class, right? We've got the logger is declared in here, and in the processor. So processor's doing two things. So what we want to do is we want to tell the processor, your dependency for logging, we're going to give you what you need to do that. That's what dependency injection is. You're injecting the dependency. So rather than repeat the word a bunch of more times, let's come over here, and I'll add a class. And we'll call it processor. And let's see, I need to make sure I add a using for log4net. And okay. So we still need the logger. So we're going to define that up in program this time though, because program is going to tell the processor what it needs for a logger. So I'm going to declare a private static. We'll even make it read only, and it's going to be an ilog, which is ilog is a log4net interface. We'll call it logger, and it's going to be equal to a new log manager get logger. Whoops. Hello. What doesn't it like there? Well, in this case, I'm doing it up in the scope of program, so I'm going to call it a program. But it doesn't like this. Why doesn't it like that? Oh, I need the parentheses. That's why. There we go. No. That's because it's static. Sorry. Log manager is not nude up there. There we go. Excuse me. So now we've got the logger. So if we wanted to, we could do something as simple as just going logger.info. Hi, folks. Run that. And even though it flashed by really quickly on the console output, we can look here in the output window, and we should see, hi folks. Okay? So we know that the logging is working. That's good. So now let's tell the processor what we want it to do. The way you inject the dependency is going to be ideally through the constructor. So what I'm going to do is define a constructor, and it's going to take in an ilog. I'm going to call it logger, and that is going to need to go someplace, so we'll declare a private static ilog, call it logger. So when we construct the processor, the logger that we pass in is the logger that the processor is going to use. Everybody still with me at this point? I'm hoping. Okay. So now we go. What are we missing? We're missing our execution. So now we can say, okay, we need a public void called execute. Logger.info. This is going to look familiar, right? In fact, it's going to look so familiar, I'm going to grab it from the other thing because I hate typing. And we just have to change this to underscore logger and this to underscore logger, and we're done. Okay? Now we just tell the program kind of the same thing we did before, right? The only difference is we're going to pass into the processor our logger. Everybody hip to that? What we're doing here with injecting the dependency. So now when I go and run this, we get the same behavior, right? That's good news. If we were writing automated unit tests, we'd be green, right? Go ahead, Julie, you have a question. Right, so Julie's question is really, it's not a question, it's an observation that we're really doing the same thing, aren't we? We're executing the... Right, we haven't removed the fact that we're doing... The responsibility, exactly. That just means that you skipped 2 slides ahead. I'm just slow walking. I'm slow walking people. You are super clever. No, you're exactly right.
Step 1, right?
Right. Step 1, so what have we gained? So what have we gained? The processor is more loosely coupled. There's not a strong dependency per se on the logging framework we've got. If I had gone the full Megillah and done this the right way, what I would do is probably define my own interface for logging. And then I'd have a concrete implementation of that interface that was done with Log4Net. And that would be the interface I'm passing into my processor. Okay, because then I can say, you know what? I don't like Log4Net anymore. It's not meeting my needs. I'm going to go with some other logging framework. Well, then I would just write a concrete implementation that matches my logging interface. And I wouldn't have to change processor. I'd just be injecting in the new version, right? So that's what we're doing. That's the benefit that we just got, was the idea that, now I skipped that part because we're still what? Depending on Log4Net ilog. So we've improved the code a little bit by reducing how tightly coupled processor is. But the bad news is it still has the 2 responsibilities. And that's your observation, Julie, with which I completely agree. What's the better way to do it? So that's what I wanted to talk about a little bit, which is this idea of a decorator pattern. Dependency injection is huge, and there's still going to be a lot of opportunities for use it, but it doesn't address the concern of single responsibility. It does give you a way to stick into your code the ability to swap out different implementations for different interfaces, and it's tremendously important, in my opinion, for things, especially when you're dealing with a third-party solution like Log4Net, or Unity, or not Unity, some of the others, anyway. Very important. It's foundational in a lot of ways to get testable code. Because you can actually write, so here's the other example. I could write a automated unit test mocking an ilog and have my processor code tested, and then that tells me whether or not, for instance, I'm logging the exceptions the way I think I ought to be. And that's a whole other topic, and I'm not going to get into that right now. So how do we address the single responsibility stuff? Well, let's talk about the decorator pattern. What the decorator pattern does is it basically gives you a way to build a chain of responsibility. No, there's a whole other pattern called chain of responsibility, so I don't want to confuse things. It gives you a way of layering on different actions as a particular action happens. We'll see. That'll become a little more clear in a second. What we've had so far is the processor and the logger, right? this is the UML diagram. I don't know, does anybody use UML anymore? Probably not. Let's just talk real briefly about what this thing is showing us, and then we'll go through, I'll code up the example with our processor and logger. This is saying that there's going to be an interface called iComponent, which has a public, that's what this plus sign means, a public method called operation. And then if we look over here, we have concrete component and decorator. Both of them have a line that goes into iComponent that connects to a triangle. That means that a concrete component is an iComponent, and decorator is an iComponent, okay? Concrete component's going to be what? The concrete implementations of an iComponent. And then the decorator is going to be this other way of defining an iComponent that does more. There's this other line, right, that comes off of iComponent. So in addition to the decorator being an iComponent, it also, this triangle, diamond shape indicates that it has an iComponent in it that we can reference, which is, in this case, it defines it as private, and then a concrete implementation of decorator. I'm not a huge fan of UML. This is one way to communicate it. I'd much rather get into the code, and we'll go through that. But it's almost like I feel obliged to show this stuff because when you go look up a design pattern, very often they're expressed as a UML diagram. I'm going to add a new project. And just like before, we're going to add log4net to it. This is a good chance, by the way, if you are starting to feel a little peakish, to go have some more pizza, because we have a lot of pizza left over. And it helps me vamp. So I'm just going to do the same thing I did before, which is I'm going to tell the decorator example app here to scan the web config for log4net settings. And then we're going to just copy our app config up here and set it as our startup project. Using log4net. So, great. Now, I'm going to be flipping back and forth a little bit here. So the first thing I want to do is I want to define the equivalent of our iComponent interface. Okay. If you think about what we were originally dealing with, right, with the processor, we can kind of infer what the interface is going to be, right? It's basically just defining the execute method, because that's really the only thing the processor really wants to do. So we're going to add a class. Sorry, I skipped. Not a class. We want to add our interface. We'll call it iProcessor. And I hate the templating. So what do we got? It's going to be a void. I'm going to call it execute. And in this case, I'm going to change the signature a little bit so that we're taking in a name. And you can think of that as when I'm processing, this would be some identifier about the thing against which I want to operate. In this case, I'll call it name because it's a string, whatever. I could call it an ID, and it'd be less meaningful in our examples further down. All right, so we've got an iProcessor. So look at this, we go check, okay, got that. So next would be the concrete implementation, the concrete component. So for that, I'm going to add a class, which is going to be our processor. I got to figure out how to get rid of that. And this implements iProcessor. And I'm just going to say, go ahead and implement it. And in this case, we're just going to do our console write line. And we'll be snarky. We'll say, hey, look, it's whatever we pass in. Come on, Rob. Okay. Actually, that's a little too snarky. Let's make it slightly less. We're processing for this person. Okay? And great. So now this, what I like about this, right? Now that we've defined processor and execute, what was the problem with it before? It had multiple responsibilities, right? Now it's just got the one. Now if I ever have to go in and change execute, it's because I want to change the way it's executing. But we don't yet have our logging. So that's where we say, okay, it's time to decorate this guy. And I reference my notes again. Let's do this. Let's add another class. And we're going to call this one, just wait one moment. Yep. This is going to be our decorator. So this is the processor decorator. And this also implements an iProcessor. I'm going to come back to this. I'm going to leave this unimplemented for the moment. Because what we need to do next is, this is where we decorate. Remember I said one of the things that the decorator pattern gives you is the ability to layer on behaviors? Our constructor is going to take in an iProcessor. And we'll store that off to the side here. Oopsie. You don't like the name? Sorry. I have to ignore that because otherwise... Yeah, okay, fine. Call it what you want. Get rid of this. Nope, no, I have to do that. Oh, Rob. Well, that's what I started off with, and then it was complete. I've got style cop on in here, so it tells me, oh, it doesn't match the rules that I've defined. But we'll just ignore the squiggly line. So the processor decorator now takes in a processor, and we store it to the side. So now what do we do? Well, now the only thing we have to do is implement execute. So this is just going to call through. Whoopsie. So what does that benefit us? It's like we just wrote a class to invoke another class. What that benefits us is now we can define other process decorators and instantiate them, one passing into the other. And we'll see that in a moment. So let's define another class. That's the one thing about the decorator pattern, is that you end up creating a lot of classes. But they've all got the one responsibility. They don't do more than they need to. Now we're going to do, we'll call it processor, because that way our classes will sort the way we want them when we look later. It's a logging decorator. And I just cleaned my code up. Okay. This guy, if I slide back over here, so we just defined the decorator, right, which is itself an I processor, and it also holds on to an I processor, right? So that's what we just defined. Now we're in the process of defining a concrete decorator, which is our processor logging decorator. So this is a processor decorator. We've generated our constructor because it needs to, you need to give it a constructor that matches its base class. And what else do I want to do? Now I want to define, because this one is responsible for logging now, we're going to need our log4net stuff again. This is where we get to introduce the log4net. So we need our private static. Let's not make it static. Let's just do read only. ilog. I'm going to call it logger. Not new. We learned our lesson about that. So now we got our logger. And this is where we get to have fun. Public override. Yep. Hello, computer. Try that again. Did I skip? Did I miss? Yeah, I did miss making that virtual, didn't I? Let's check my notes. Yep, that's what it was. So what I forgot to do was in the processor decorator, because we're saying we want to be able to obviously create subclasses off of this, which will be a concrete decorator. If I want execute to be available to be overridden by the subclass, you have to mark it as virtual, and that's what I forgot, is that keyword. So, whoopsie. Now if I go to our processor logging decorator, I can override executes. And by default it says I want to do a base call on execute. But before we do that, let's say that we want to log. Whoopsie. So before execute in processor was doing multiple things, right now we're just saying we're just going to log, let the base class do its thing, and we'll log again. Okay? That's it, in a nutshell. I never have to go in. Let's say I change the way I want to do execute on the processor. I won't have to change how I do logging for that and crack this code open. I can just go change processor. if I want to change the way I do logging, I don't have to open up processor and touch execute. I just come over to the processor logging decorator and touch that. That gets us to our single responsibility. So let's run it. Let's see what it looks like. So here, I'm back at the program. And I don't think I need very much out of here, but let's go forward with this. I'm going to need an iProcessor. We'll just call it P. It's going to be a new, whoopsie, new processor. And for the sake of clarity, I'm going to do 2 runs through this. So first time we'll just do basic. Okay? We're just saying this is a basic processor. I'm going to give myself a line of dashes. And we'll call P execute Julie. All right? If I run this now, what? If I run this now, I'm going to need to say console.readline. Otherwise, I won't see it. It'll go so fast. Hey, we're processing for Julie. So we know that we got the processor done. That's great. I didn't log anything because processor doesn't log anymore, right? It's only responsible for doing its thing. How do we get logging back? We do this. You define an iProcessor. I'll just call it L. Well, we'll spell things out. Log decorator. It's a new it's a new processor logging decorator that's going to take in P. And just for the sake of clarity here, that's just basic processor. Okay? I think that's all I have to do. Let's now call, rather than calling processor execute for Julie, we'll call the log decorator execute for Bruce. Okay? And you know what? Let's give ourselves a similar kind of way to differentiate. This is the decorated processor. Everybody clear on what we're doing here? So I'm going to run this. So now we ran the basic processor, and that gave us, hey, we're processing for Julie. We newed up the log decorator, and we said we want to execute for Bruce. Not only did we, no, I gotta click this as mark. Yeah, come on. We follow the bouncing clicks. Not only did we process for Bruce, we also logged. We said we started execution of Bruce. We're done with the execution of Bruce. What?
Poor Bruce.
Poor Bruce. We've executed Bruce. And that's what, I mean, at the basics, I mean, that's what the decorator pattern does. Now you can imagine that we could do the same thing. Remember all those cross-cutting concerns I mentioned before? Caching, authentication, authorization. All that stuff can be handled the same way. You could, we could easily mock up a processor caching decorator where.
And then you just pass the process
around. Right. So let's say, let me get out of here. It'll give us all kinds of squiggles if I do this. But let's say, for example, we defined a iProcessor called cache decorator. And that's going to be equal to a new, I hate typing. Actually, I could do log decorator, right? And then instead of a processor logging decorator, hashing decorator. So now you see we declare our first processor, our second processor is decorated, right? Every time we execute, we can then call the next one, and it'll layer them on.
It's funny,
So Julie's observation is that it seems a little backwards because you're not calling processor.execute directly. It's getting called indirectly through the decorators. And that's true. It might seem more natural if it were managed more through better naming conventions, maybe on my part. I don't know. Yeah.
So I get the gist of it.
So Carl's observation is that this looks really good when you're dealing with single line executions and you're kind of embedding things in there, but that if you have methods that are much longer and you maybe want to log at different points along the way within the execution of the process, that now you're talking about either decomposing that process, that execute process, maybe beyond what you'd really want to do, or if you're not going to do that, what other strategies are there? So, and I know you said you wanted to jump in.
Yeah, I was thinking that maybe given the beauty of dependency injection, execute could call itself. It's clear in my head. But if you have this structure, you can use the execute function to call the execute function. You can invert the inversion, so to speak. Your logger could, you could have a processor that receives the log. Going back to the
Okay.
structure.
So one thought was maybe there would be a way through recursion of having the logger invoke the execute and vice versa. That's not the approach that I would take, because I thought about this as well, Carl. The solution that I came up with, and we can go through this, I think it'd be an interesting experiment, and I certainly have time because for the most part I'm through the presentation at this point. So we have time to experiment a little bit. But the solution I came up with was to raise events at different points during the execution, and then the logger would then subscribe to those events, right? So the logging decorator would observe the processor and say, oh, if processor hits step 37 and it raises the event, I can handle that by doing another log thing. And that was my workaround for that. Now,
do you happen to have more complicated code, like more advanced codes, like that you can show? Like
No.
that's public?
no, this is the thing. One of the reasons why I do the presentations is because I'm learning this stuff, and I want to start, as I can, folding it into what I do in the office.
Right.
I haven't gotten to the point where I've actually implemented this in a non-trivial way just for the I mean, really, it's been for the presentation that I've been getting my head wrapped around this, so I don't have an example.
A really good way of explaining it to other people is a great way to
Exactly.
lock it in.
Yeah. Yes.
How is this different than in Outlook?
Right, so the question is, can you accomplish the same thing and maintain the single responsibility through inheriting the processor? I guess my feeling is that if I'm it starts to dilute the is-a concept. So if let's say we have processor and then a logging processor, it starts to dilute whether or not it's a processor or whether it's a logger. Whereas the decorator, it's just by virtue of the fact you're following this design pattern. And remember, design patterns are nothing more than conventions that give programmers a common language about which to talk about code. So if you say this is a processor logging decorator, even in the name it kind of implies, it's kind of declaring what it does. Whereas if you start to do it through inheritance, I would argue that you're still suffering the that you're still assuming multiple responsibilities within the class. It's just that it's throwing it back up to its base class, or shoving it down into the subclass.
That's kind of what we're doing here too.
No, not really though, because what we're calling in the execute on the logger isn't my parent. I'm calling the thing that I got injected, which is the processor. Again, we're doing it a little bit through. Actually, we are calling the base, aren't we? Yeah. So Steve's point was that some of the examples that he's read online kind of make it easier to see the benefits of this by doing a more non-trivial implementation, and you can start to see the benefits of it. So the observation was that inheritance versus using like a decorator pattern, it kind of is more. It spells out more the intent. It states an intent, so that inheritance is really more about stating an intent to use polymorphic behaviors, whereas a decorator is kind of extending behaviors through different means.
This kind of goes in like just the next baby step.
Okay.
It might be interesting to look at.
Julie's
So
providing
it's-
a link, so I'm going to type that in, and you were going to make an observation or make a question. This image comes from this is DoFactory.com, which has a lot of examples for .NET of different design patterns, and this is from the Decorator design pattern document that they have. And I just opened the image up in a separate tab. So this should look familiar, right? This was the one that we started off with. What they're calling out in this that the other document didn't, is that you can see, for example, a decorator can then implement additional behavior. So it's not just limited to kind of restating execute again and again. In this case, you can call the base operation and then do added behavior. So that added behavior may be the logging, it may be caching, it may be something else beyond that. And then you still have access to invoke the members of the component that was passed in addition, and in different timelines, right? Or orders of execution, not timelines, orders of execution. So this is from DoFactory Decorator pattern. So there's an app where they define a book and we display the book. And we create a video and display the video. And they're making the video borrowable. So
borrowable is the decorator.
borrowable is the decorator. Okay. Right. Or which decorators, yeah, so the idea of having the factory generate the decorators and the processor as well. And then you can loop that in. If you're defining an app, let me just finish the thought, Julie, I'm sorry. You could have a factory generate that, and maybe the way the factory generates the decorated processor is determined based on your user preferences or your configuration, right? So now the factory is going to generate it with, oh, do I need to include logging? Yes, okay, now I decorate it with logging. And then it just comes back out as a processor decorator that I then use throughout my application.
But when Julie wants to use a processor, she doesn't have to remember which decorators.
Right.
And that's
Right.
That's it. That's the aha.
Right.
I got it.
But I can't just present to you, oh, I didn't want to just present to you like, oh, we're going to completely encapsulate it so you don't have to think about it. But if you're going to carry this to a full-fledged application, that's definitely the way you go. The idea was to get comfortable with what it's doing.
It makes sense, but
Yeah.
that's why it felt backwards to me, because I thought that was the thing I needed to interact with.
I see. Yeah. I'm sorry, Carl, you had a...
Siblings or how did
They're siblings is one way to think of it. So if I go, so remember we started to just kind of monkey around with, in here, the caching, right? So take away all this extra goo, right? I'm going to take away this. So now I would do, what was the one? Validation. iProcessor, validation, decorator. decorator equals new processor.
I think the stickiness of this example comes in naming your objects after their classes. You would call, like, what you have called processor, you call it like namesayer or something. And then log decorator would also logging.
Oh, I see. So rather than log decorator, maybe just log processor, or
Logging processor.
logging processor.
So, okay, so we have that set up now, so how do I actually do my process?
You call.
You would call, so let me just go through and I'll just rename these real quick. Caching processor, validation processor. So then what you would do is you'd just call validation processor dot execute Carl, like that. And it's gonna validate, it's gonna cache, it's gonna log, and it's gonna do the actual munging of the Carl that you need to have done. Yeah, Pluralsight does have a lot of good session, videos about design patterns. I did the Pluralsight one on JavaScript design patterns. I went through that one. I didn't go through the others. But here's the beauty part, right? Like I said, is design patterns are language agnostic in many ways. As long as there's a feature set that are supported, like, you very often have to have interfaces, right? If you're going to do a design pattern. But once you get the design pattern in one language, you can apply it in many others. So I haven't seen the Pluralsight design pattern series. I suspect, based on some of the other Pluralsight videos I've seen, that, I mean, depending on who does it, it can be very, very good. And none of them really suck. So, yeah. Yeah. Yeah, the Head First Design Patterns book really helped me. Just like I said, I didn't always love the examples, but it was eye-opening to me. It was one of two books that, like I said, I did a lot of Oracle early on. The Stephen Feuerstein book, Programming Oracle PL SQL, that was the first book that it brought me to one next level as a developer. And then the design patterns, Head First Design Patterns, kind of upped my game again.
So what do you think is a better book than just the Gang of 4 book? I mean,
I've thumbed through the Gang. Here's the thing. I've thumbed through the Gang of 4 books. And that one is very, I mean, that's the Bible, right? If you're going to learn them, that's the one to learn. And I have to work hard at really technically dense stuff.
Yeah.
And that book is very technically dense. The Head First Design Patterns one, that may be too bubblegum for some people, but it was just right for me at the time when I read it.
Yep.
Now, if I could find a middle ground, then that would be perfect. I think, Julie, you need to write another book, frankly.
No, but there are, the Design Patterns Library, there are so many courses in there. I think there's 15 hours worth of different courses in there. It's like the Decorator pattern one. Oh, and they're by
So I'm just gonna let's put a fork in this thing. I went through that, and then it was questions. So we've certainly been having those. So I'm gonna call that done, and we can keep talking. But for the purposes of recording, I'm gonna stop.
Okay.
Okay, and I'm gonna laugh at Adam because he just blue screened.
That's black screen.
No, you blue screened before you went black.
Oh, serious?